Story time. So I'm walking to my biology class, right? And I look at the assignment and it started talking about some biology stuff, some science. And I'm like, okay, cool, cool, cool. So I scroll down and I see standard deviation. I'm like, what's that? All right, so what does standard deviation mean? By definition, standard deviation is the measure of a data set's dispersion from its mean. Now, in simple terms, that just means how far spread apart is the data set. So let's say you have a mean or an average of 10. You probably have data points ranging from 0 to 20, but the thing is, how far spread apart are they? Are there more numbers in the double digits? So maybe you have 5 out of 10 numbers ranging from 15 to 20, or do you have more numbers in the single digits? Maybe you have 7 out of 10 numbers ranging from 0 to 5. So standard deviation is mainly just looking at how spread apart your data set is. All right, guys, here we have the standard deviation formula. Yeah, that's how I reacted when I first saw it, because this looks like a lot of gibberish. However, with some practice, you'll be good to go. So looking at this formula, the basis and really the goal when looking at it is to just understand the steps behind it. Once you understand the steps, you don't even have to really recognize the formula as much. Just recognize the steps and the process to finding standard deviation. So here we have a whole bunch of symbols and letters. However, let's start with our parentheses. So we have here xi, which is represented as 1 going on, continuously. We have our xi or x1 minus this x with the line on top. So that x1 represents your numbers. So let's say you have a couple of numbers. Let's say you have 10, you have 20, and you have 30. Basically, you subtract those from this x with the line on top. That represents the mean or the average. So 10 plus 20 is 30, plus 30 is 60. The average of 60, well, basically the average of our data set is 60 divided by 3, which will be 20. So then what you'll do is you subtract each number. So we have 10, we have 20, and we have 30. So 10 minus 20, which is the average, is going to be negative 10. 20 minus 20 is going to be 0, and 30 minus 20 is going to be 10. So those are going to be our deviations, or basically how far apart our numbers are from the mean. Now, after we get that, now you see we have a squared number right here. So everything here is raised to the second power. So that just means all our deviations are going to be squared. So negative 10 is going to be squared, which gives us 100. 0 is going to be squared, which gives us 0. 10 is going to be squared, which gives us 100. So all together we have 100 plus 0 plus 100. That'll give us 200. And basically that's what this symbol right here means. So that just means we add up all our squared deviations. So that gives us 200. So if I were to be solving this, I would erase all this at top and just write 200, because that's what we just got. And then after that we get n. So we divide the 200 by n minus 1. So what does n mean? N is basically the number of numbers we had. So let me explain. We had a 30, a 20, and a 10. We had a 30, 20, and a 10. So those are 3 numbers. We're going to take those 3 numbers and subtract them from 1. So 3 minus 1 is 2. So then what we'll go ahead and do is our 200 on the top is going to be divided by the 2 on our bottom, which gives us 100. So let's go ahead and stop there. We have 100. That is going to be what is called the variance. Let me repeat it again, the variance. So after you subtract and do all that good stuff, you square all your deviations and so on, all of the steps within this square root sign is called the variance. After you find the variance, which in this case is 100, we're going to go ahead and find the square root of that. So the square root of 100 is 10, and that in this case would be your standard deviation. Now let's go on ahead and look at a real life example. So here I have a data set of 5 numbers, 70, 60, 50, 40, and 30. We want to find the standard deviation, but how do we do that? So following the steps we learned in the formula, let's go ahead and apply that here. So the first step, if you remembered, is to find the mean, or in this case, you could also call it the average. How do we do that? We add all these numbers together, which is 250, and we divide it by how many numbers we have. 1, 2, 3, 4, 5. So 250 divided by 5 is going to give us 50. So let's write that up here. 50 is our mean, or our average. Now the next step is to find the deviation. How do we do that? The deviation is basically how far away all these numbers are individually from our mean. So 70 minus 50 basically is just asking us to subtract all these our individual numbers from our mean. So 70 minus 50 is 20. So if we were measuring in feet, I would say 70 is 20 feet away from 50 feet. 60 minus 50 is going to give us 10. 50 minus 50 is 0. 40 minus 50 is negative 10. And 30 minus 50 is negative 20. Now that we have all these numbers, the next step is to square our deviations. So our deviations are right here, which is basically what we just finished doing. And we're going to go ahead and square them. So 20 squared, or 20 times 20, is equal to 400. 10 squared is equal to 100. 0 squared is equal to 0. Negative 10 squared is equal to 100. And negative 20 squared is equal to 400. So now let's go ahead and erase all this to free up some space. So the next step we're going to go ahead and do is we're going to go ahead and add up all of our squared deviations. 400 plus 100 is 500 plus 0 plus 100 plus 400 is going to give us 1000. So let's erase all this. So the sum of all our square deviations is 1000. 1000. So now that we have 1000, now we're going to subtract this from the number we have here, remember, which is 5. We have 1, 2, 3, 4, 5 different numbers minus 1. So if you remember in the formula, it was written as n minus 1. N is how many numbers we have, which is 5 minus 1. So 5 minus 1 is 4. 5 minus 1 is 4. 1000 divided by 4 is going to give us 250. 1000 divided by 4 is 250. 250. So now we are at our variance. This is what we call the variance in, I guess you could say, statistics, biology, whatever you want to call it. It's called the variance, 250. Now we're going to find the square root of 250. The square root of 250. The square root of 250 is going to be equivalent to, I believe it's 15.8. 15.8. So now we have 15.8. So now this is our standard deviation. However, in some places, they would expect you to know the significant figures. Now, we're not going to go too deeply into this in this video because it's a whole nother topic on its own. However, the significant figures is basically just how many digits do you have in basically each of these numbers. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. We have 2 digits. So we're going to go ahead and round to the 2 digits we have here, which is our second digit is going to be our ones place value. So 15.8 rounded to the nearest ones is going to give us 16. So therefore our standard deviation is 16, which is basically, you know, how far away together as a whole are all of these away from our mean or our average. So the standard deviation for this whole data set, let's go ahead and box it or circle it, is 16. All right, and a quick tip for my biology students, you're probably wondering, what about significant difference? All right, so significant difference goes this way. So basically you have your equation, which is the mean plus or minus half of the standard deviation. So always keep that in your head. Now you have 2 data sets. Well, unless you wouldn't have a significant difference. So you'd have data set A and data set B. Now, to find if something is significantly different, you'd first have to go ahead and find the mean for the first data set and the standard deviation, as well as the mean and standard deviation for the second data set. After you did that, you're going to get your mean for data set A. You're going to add it. So this is the plus or minus sign. So first you're going to add it to half of the standard deviation. And also you're going to get the mean of your data set A and subtract it from half of your standard deviation. So let's say you ended up with two different numbers, 10 to 12. So that's probably so 10 is probably going to represent maybe your mean A minus half of your standard deviation, and 12 is going to represent your mean A plus half your standard deviation. Now, we're going to keep this number here because there's a rule that we're going to follow at the end. Now, you're going to do the same thing for the data set B. Mean B plus half the standard deviation, as well as mean B minus half the standard deviation. So let's say you ended up getting 14 all the way to 17. The rule for standard deviation is this. If these two numbers don't overlap, so 10 to 12 will never overlap 14 to 17 because it has a gap of the number 13 in between them. So because these two number sets don't overlap, that means they are significantly different. So in biological terms, that just means that these things are different because of whatever reason, not just because of maybe natural variables and all that good stuff, but they are significantly different. Hey, if you enjoyed that video, go ahead and like this up. And yeah, that's about it, guys. Click on these two videos if you need any math help. Make sure you subscribe and also comment in case you have any other math questions, not just in mathematics, but maybe, biology or chemistry. Feel free to drop them in the comments, or you could DM them to the Math by Isaac Instagram. Also, go give them a follow. Have a great day, guys. God bless.